Today we're going to be looking at polar coordinates. We're going to be talking about what is a polar coordinate system. Polar being, think about it as sort of a magnified unit circle. Okay. Now, the polar coordinate system for a fixed point, that would be this guy right here. There's your fixed point that is called the pole. Okay. Or the origin, since it's at 0. From 0, we construct an initial ray. 8. That would be this guy right here. That thing is called the polar axis. Each point on the plane, that would be this guy here, P, is assigned a polar coordinate. That polar coordinate is r theta. R is the length here. That would be this chunk. And theta is the angle from the polar axis to get to that chunk r. Okay, so r is the directed distance and theta is the counterclockwise angle. All right, now, when r, that's this guy right here, is negative, then we're going to actually graph the point the exact opposite of where it's at, which means that it's going to be 180 degrees or pi from where it would be if it were positive. So we plot it, instead of r theta, we're going to plot it as r theta plus pi. Okay? So let's look at graphing polar coordinates. We use a polar coordinate graph, and if you look at the polar coordinate graph, that's what we're talking about. And remember when I said the unit circle? Well, the unit circle would be the innermost here. This is the unit circle right there. Now, notice that it has, that's a half. The full unit circle for this guy, since 1 is here, is this would be the unit circle. All right? So you'll notice we have pi over 6 and pi over 4 and pi over 3 and pi over 2 and 2 pi over 3 and 3 pi over 4 and 5 pi over 6 and so on, like you're used to. Literally the unit circle. Just think about taking the unit circle out. 1, 2, 3, 4, 5 units instead of just 1 unit long. We're just more concentric circles after that. All right, hopefully you understand that. So now, how do we graph on the polar coordinate system? Well, easy. We go to the location first, and then we go out to that spire. Okay, so 7 pi over 6. 7 pi over 6, we would go all the way around to 7 pi over 6 right here and go out. Since this is by halves, 1/2, 1, 1.5, 2, it would put it right here. And this would be the point A. Around to 7 pi over 6, out to the circle that's marked 2. All right, B is 0.5, 3 pi over 4. So we know 3 pi over 4 is right here. So this is 3 pi over 4. And we want to go out a half. So from the center, following this spire, we go out to the halfway mark. So B would be here. All right. So negative pi over 3. All right. So first thing we do is take negative pi over 3 and add pi to it. And that will tell us where to go. So negative pi over 3 plus 3 pi over 3 puts us at 2 pi over 3. So really what we're graphing is 2 pi over 3. So we go over to the 2 pi over 3, which is here, and go out to the 3 bar, which would be out here. So this would be right here. C. D would be -1. Oh, wait a minute. This is, I made a mistake. What did I not pay attention to? What does this say? It says when R is negative. Well, R wasn't negative here, was it? See, easy mistake to make. R is not negative here. Come on. R is positive, so we need to do, so in this case, negative pi over 3 would be the same as negative pi over 3 plus 2 pi, or 6 pi over 3, which would be 5 pi over 3. So we're really doing 5 pi over 3. We'll do the next one. That is where r is negative. So we go out to 5 pi over 3 and 3, so C is actually here.
Good morning.
All right, so now let's get to this. This is my negative r.
Please stand for
So-
the Pledge of Allegiance. I pledge allegiance.
So we have a negative r here, which means we need to take pi over 4 and add pi to it. So that means 4 pi over 4. So this is 5 pi over 4. So really what we're doing is 5 pi over 4 instead of negative 1 pi over 4. So pi over 4, 3 pi over 4, 5 pi over 4 would be here. So 5 pi over 4 would be here, so this is point D. E, negative 2.5. Again, we have a negative r, so we have to take 4 pi over 3 and add pi to it, which would be 3 pi over 3. So we end up with 7 pi over 3, positive 2.5, 7 pi over 3. All right, so 7 pi over 3 is more than 2 pi around, isn't it? So now we got to do the stupid thing of saying, okay, where's 7 pi over 3? So since this is more than 2 pi, we're going to subtract 2 pi from it, which would be 6 pi over 3, which really leaves us at 2.5 pi over 3. All right, so pi over 3 is here. So we're going to go 1/2, 1, 1/2, 2, 2.5. So this would be E. Now, an easier way to do some of these might be to say, if we were to do 4 pi over 3, 2.5, 4 pi over 3, 2.5 would be here, but because it's negative, we would literally flip it across the axis to this, 180. We would go 180 around. So sometimes it might be easier to think of it that way. So you could really say, maybe it should be here, but then 180 degrees from that really puts it here. So you can think of it that way if it makes more sense to you to do it that way. All right. So 180 degrees this away puts it actually there. So let's try another one that way. Negative 3, negative pi over 6. Okay, so the first thing is we got to get negative pi over 6 as a positive. Negative pi over 6 plus 2 pi, which would be the same as 12 pi over 6, is negative 3, 11 pi over 6. So if we did that, 11 pi over 6 is here. Negative 3 would be here, but now we want to actually take that all the way across in a straight line, 180 degrees, right? So 180 degrees would take it all the way around to here, which makes it actually be here, 5 pi over 6. Now, if you don't want to treat it that way, you can always add or subtract. Remember, you could actually subtract pi also, which would put it at 5 pi over 6, okay? So another way to think about it is if you were adding pi and it was going to make it too big, you could always subtract pi instead, which would have taken us straight to here and you wouldn't have had to mess with this mess here. So you can either add pi or you can do theta minus pi because it's 180 either way, isn't it? But remember, we only do this if it's going to if it would end up bigger than 2 pi, okay? So either way. All right, so while each pair of polar coordinates plots a unique point, each point does not have to have unique coordinates. In general, a point with polar coordinates are theta, we just figured out. You can go around the circle plus 2 pi or multiples of 2 pi n, or you can flip it around and make it multiples of pi n, which is where n is any integer. All right. So basically what you're going to be doing is this. We have 5 pi over 3. Well, 5 pi over 3, now we have to keep it between negative 2 pi and positive 2 pi, which means what we're going to do is either do plus or minus 2 pi, multiples of 2 pi. So if we take 5 pi over 3 and we add 2 pi to it, that is going to be the same as 6 pi over 3, which is going to be what? 11 pi over 3, which is greater than 2 pi, so we can't do this plus. So that doesn't work. So what we have to do instead is take 5 pi over 3 and subtract 2 pi from it, which would be the same as 6 pi over 3, which would give us negative pi over 3. So there's one option. So now we have 2 negative pi over 3. And let me reiterate, you either add 2 pi or you subtract 2 pi to get one of your coordinates. So that's the first one, 3 different pairs. So the first one is you either, so first, add or subtract 2 pi. Okay, now for the next one, you're going to flip the sign. So instead of 5 pi over 3, we're going to switch it to negative 2 something. Well, remember, we said we could either add or subtract pi, couldn't we? So let's add pi and see where we get. Let's subtract pi and see where we get. Or we might have to subtract pi twice or 3 times because this is a multiple. So let's take 5 pi over 3 and subtract pi from it, which would be 3 pi over 3, which leaves me with 2 pi over 3, which works. So this goes here, and we're left with 2 pi over 3. Now, we're going to take that to 5 pi over 3. This is going to become negative 2 something. So now we either have to take 5 pi over 3 and add pi to it, but if I add pi, so if I added pi, this would be 3 pi over 3, which would be 8 pi over 3, which would be more than 2 pi, so I can't do that. So what I have to do instead is I have to subtract again. So now I'm going to subtract, but I can't subtract pi. I already subtracted 2 pi, so now I got to do odd multiples. So instead of 1 pi, I'm going to subtract. This is the same as 1 pi. Can't do 2 pi, I have to do odd multiples. That's what this means. Odd multiples of pi. So the next odd multiple would be minus 3 pi, which would be what? 9 pi over 3. So this would be negative 4 pi over 3. So that would be my next one. Okay? So let's try another one of these so you can see how it works and make sure you understand it. And yes, Nick, you can. Remember what it said. It had said we can't go past 2 pi. So here we go. We're starting with a negative this time. So now we're going to do first step. We're going to do this in terms of 3 different things. So the first one's going to be negative 5, comma something. We're going to take negative 7 pi over 4, and we said we were going to add 2 pi to it. Well, 2 pi is 8 pi over 4, which leaves me with pi over 4. Cool, that's within the limit. So pi over 4, that goes here. And here's my first answer. Now I'm going to take negative 5, negative 7 pi over 4. Change this to a positive 5. change the sign on the first one, and I'm going to take my negative 7 pi over 4 and I am going to add pi to it. So I'm going to add pi, which would be 4 pi over 4, and that gives me 3 pi over 4. Boom, that goes here. Yay, here's my second one. Now I'm going to take negative 5, negative 7 pi over 4. This changes to positive. And then I'm going to take my negative 7 pi over 4, and I'm going to add the next multiple of pi to it. The next odd multiple, we added 1 pi, so now we're going to add 3 pi. 3 pi is the same as 12 pi over 4, which is 5 pi over 4. So that goes here. So you've seen this happen twice. Last time, maybe it'll kick in this time. 1, 2, 3. So we're going to stick with the number the same the first time. We're going to take this and we're going to add pi to it. So this becomes 6 pi over 6, which is 7 pi over 6. Boom, goes here. Here's my first coordinate that's the same. I'm going to take negative 1.5 pi over 6. I'm going to change this to positive 1.5. I'm going to take pi over 6 and add pi to it. Okay. I just screwed this up. Let's try this again. Keep this, negative 1.5. Take pi over 6 and add 2 pi to it. If I add 2 pi to it, it's going to be greater than 2 pi, so guess what I have to do? I have to subtract 2 pi from it. So just like we did here, we added 2 pi, it worked, but now we can't do that with this one since it's positive. We have to subtract 2 pi from it. 2 pi would be 12 pi over 6, so this makes this actually negative 11 pi over 6. That's what goes here. I'm so sorry, guys. All right, so now, this one, we change negative to positive and we add pi to it. So this is 6 pi over 6, which is 7 pi over 6, which goes here. Coordinate number 2. Now, negative 1.5 pi over 6. Keep the negative 1.5. Now we would take pi over 6 and add 2 pi to it. But if we add 2 pi to it, it's going to be greater than 2 pi, which we can't add 3 pi to it. Guess what we have to do? We have to subtract 3 pi, or better yet, we could subtract 1 pi. Yeah, let's subtract 1 pi, which is 6 pi over 6. So negative 5 pi over 6. So now we get negative 5 pi over 6. So guys, this is going to take a little bit of thought to it. But to reiterate, step 1, we're going to either add or subtract 2 pi from it. Step 2, we're going to either add or subtract pi from it. Right? Step 3, we're going to add or subtract pi or 3 pi from it. Knowing that how you guess is you're going to try it, and if it ends up bigger than 2 pi, you have to do the other one. Okay? So those are the possibilities of what you do. All right, so now How do we find the distance between two polar points here and here? There is a formula, and you just need to know the formula. You take r sub 1 and square it, add r sub 2 and square it, and then subtract twice r sub 1 times r sub 2 times the cosine of the angle between 2 and 1. And if you notice, this actually is the cosine formula for law of cosines, okay? That would be the distance, P1, P2. Absolute value, because distance is always positive. So we're going to label this r sub 1, theta sub 1, r sub 2, theta sub 2, and we're just going to plug in the formula. The distance, p sub 1, p sub 2, is going to be equal to the square root of 2 squared plus 3 squared minus 2 times 3 times the cosine of 7 pi over 4 minus pi over 3. So now, square root of 4 plus 9 minus 12 times the cosine of what? So this is where we go over here and we say, okay, 7 pi over 4 minus pi over 3. Common denominator would be 12, so times 3 times 3 times 4 times 4. So we get 21 pi minus 4 pi over 12. So that makes this 17 pi over 12. That is not on the unit circle, so you're just going to use your calculator in radian mode. Make sure your calculator's in radian mode. Okay? If you're here or you're dealing with this. Now, if it's here like this, then it's in degree mode. And then it's just a calculator problem. You should get the square root of approximately 16.1058, which is about 4.01. Let's try one more of these. Let's do one that's in, say, degree mode, which is actually easier. So the length between P1 and P2 is equal to the square root of R1, theta 1. This is R sub 2, theta sub 2. 8 squared plus negative 2 squared minus 2 times 8 times negative 2 cosine of 310 minus negative 175. All right. Square root is 64 plus 4. Negative times negative is a positive. 4 times 8, so plus 32 times the cosine of, this becomes plus 485 degrees. So that is the square root of about 49.6456, which is approximately 7.05. Okay? Calculator work. Don't be afraid of 13. This is still just r sub 1, theta sub 1, r sub 2, theta sub 2. Plug them into the formula. Okay? And just remember to put your units with them. So the answer would be, for this guy, if you want to try it, is approximately 39.97 miles. Okay? Because it's miles. And then finally, these guys are easy. It's just a formula. The only ones I can see you having a little bit of trouble with maybe are these, and those you're just going to have to practice and struggle with. All right, do your homework. All right. Polar equations. What is a polar equation? Polar equation expressed in terms of r and theta instead of x and y. Now we're in r and theta. For example, r equals 5. That would be a circle because the radius is 5 everywhere. R equals 3.5 sine theta, or r equals negative 6 cosecant theta. All right, so r equals 2 simply means the radius is 2 everywhere. So this is 2 right here if you look. Whew, get in there close. See, it says 2 2, 4, 6. So r is 2, means the radius is 2 everywhere. It doesn't matter about the angle because theta's not in there. So that would be the graph of r equals 2. Simple enough. How about r equals negative 4.5? Well, negative 4.5 simply means that you would go to one of these, like pi over 6, and we would go 1, 2, 3, 4.5, but then it would, because it's negative, flip over to the other side here at 4.5, but does that really matter? It's going all the way around. It's still r. So it would still just be all the way around. So r equals negative 4.5 is the same as r equals 4.5. Now, what happened if it's just theta? If it's just theta, that means it's just an angle at pi over 3. That means everywhere here is going to be pi over 3 going this way, or if r would be negative, it would be this way. So guess what? If it's just theta, guess what it graphs as? So just theta graphs as a straight line. So just r graphs as a circle, and just theta graphs as a straight line. So negative 7 pi over 6. So negative 7 pi over 6 means we have to add 2 pi to it, which would be 12 pi over 6. So theta is actually 5 pi over 6. So at 5 pi over 6, we're going to put a line all the way through here. Arrows on both ends. Now, where it gets a little tougher is where it's both r and theta. So what we have to do is plug in, okay? So we're going to plug in thinking about our unit circle. If we plug in 0 for theta, this is really 2 sine of 0 degrees. Sine of 0 is 0, so this is 0. So at 0, it's 0, okay? This is 2 times the sine of pi over 6. Sine of pi over 6 is 1/2, if you remember. So this is 2 times 1/2, which is 1. So at pi over 6, this thing is 1. At pi over 3, this is 2 sine pi over 3. Sine of pi over 3 is root 3 over 2. So this is just root 3. Root 3 is approximately 1.7. So this is about 1.7. So at pi over 3, we are now at 1.7. So we're almost to 2. There's the 2 ring, so we're about here. Okay, so you can see what's happening. Pi over 2. 2 sine pi over 2. Sine of pi over 2 is 1, so this is 2. So at pi over 2, this is going to be 2. So right now what we're seeing is this. Now, let's finish it out and see what we see. 2 pi over 3. 2 sine 2 pi over 3 would be 2 times what? Sine of 2 pi over 3 is the same as pi over 3. So this is root 3 over 2. So this is again root 3, which is about 1.7. So 2 pi over 3, it's now 1.7 again. Oh, I'm seeing it. Pattern. How much you want to bet at 5 pi over 6? It's the same as if it would be at pi over 6. So let's see. 2 sine 5 pi over 6. Sure enough, 2 times 1/2, which is 1. So 5 pi over 6, it's now at 1. And then at pi, we've got 2 times the sine of pi, which is 0. So this is 0. So we're back to here. Boom. Now, 7 pi over 6. 2 times the sine of 7 pi over 6 would be 2 times -1, which would be -2. So at 7 pi over 6, it would be at 2. So 1, 2, -2. But remember, 180 would bring us back around to, oops, sorry. Having a rough day here. It's not 1. 7 pi over 6 is 1/2. So it'd be -1/2, -1. So at 7 pi over 6, it would be -1, but then we would have to take it around, and look, it ends up back here again. So it's here again. So if I were to do these at -1, I would see it was here. Okay, so we did 0 and here. So this was 0, that was there. Do you see what's going to happen here? This is going to end up at -√3, -2, -√3, -1. So it ends up going and doing this again. So we end up with, this is the graph. So every time you're going to have to fill in a chart like this to graph. Look at this other one that we had. We had 2 sine theta vertically from 0. So this would be vertically from 0 to 2. And look, from 0 to 2 vertically. And we made a circle. Same thing. You don't even have to do this anymore because we know what it's going to look like. These are the only ones. Graphing the polar equations, those are simple. If it's r or theta, you know that. Those are really easy to size. So graph each polar equation by plotting the points. So let's try another one here. How do we do this? Now, cosine. R is equal to cosine of theta. Okay, so we're going to go over here, and we're going to do enough to see what's going on. This is theta, this is r. So we're going to start with 0. So cosine of 0 is 1. So at 0, it is 1. So it is here. Then we're going to go to pi over 6. Cosine pi over 6 is √3 over 2. So this is approximately 1.7 of that. Where's my calculator? Let me grab my calculator, guys. Put myself in radians. So cosine √3 over 2. Okay, so √3 divided by 2 is about 0.9. So at pi over 6, it's about 0.9. All right, so at pi over 3, cosine of pi over 3 is 1/2. So at pi over 3, it's now 1/2. So we're doing this. At pi over 2, it is 0. So at pi over 2, it's now at 0. So we're here. At 2 pi over 3, cosine is what? At 2 pi over 3, it's going to be negative, isn't it? So 2 pi over 3 would be -1/2. So at 2 pi over 3 would be 1/2, but then it would flip across here, so it would be -1/2. So now we're making this. At 5 pi over 6, it's going to be -0.9. So at 5 pi over 6, it would be almost to 1, but then we would flip across and it would go to here. Boom, I see what's happening. And at pi, it's going to be -1. So at pi, it would be 1, but then it would flip back to here. So here we go. And what you're going to find is it's going to repeat like that again. So if we kept on going, we would see it repeat all the way around. So we're good here. We've got the graph. Let's try one that's like r equals, well, we've done a couple of those. Let's try one of these. R equals cosecant. Cosecant is weird. Secant and cosecant graph differently. Let me give you a hint that makes this super easy. If it's just cosine or it's just sine. It's going to be a circle. Cosine is going to graph horizontally from 0 to whatever number's in front here. There's an implied one right here. The coefficient in front. Okay, sine is going to go vertically. From 0 to coefficient in front. So let's see if that actually worked. It worked. This one would be from 0 to 1 horizontally. So this guy would be from 0, vertically from 0 to -3. So from 0 to -3 here. And then you just have to fill in a couple of points, okay? And get it. But you got the general idea of what it's going to be. All right, and it would be halfway at your let's see if we can figure out where would it be halfway. For this, it would be pi over 6. Halfway would be wherever the sign would be. So it would be halfway. Half would be pi over 3s. But for sine, half is pi over 6s. So halfway at pi over 6s. So at 7 pi over 6, it's going to be half of 3 would be 1.5. So half, 1, 1.5. At this pi over 6, half, 1, 1.5. So this, guys, is really enough to figure out what this guy is going to look like, isn't it? Gives me a circle. We can do one more here. For cosine, I want you to think about it. Cosine says it's going to be horizontal, 0 to 4. So we know it's going to be 0. We know it's going to go all the way out to 4. It'll be halfway at, cosine is half at what? Pi over 3s. So halfway at your pi over 3. So pi over 3s, half of 4 is 2. So at pi over 3, it's going to be at 2. And it's going to be halfway. So there's pi over 3 is 2. So we know the circle is going to look like this. Is that not so much easier? I know, you love me, don't you? I give you all the shortcuts. Now, cosecant and secant, here's your hint. Cosecant and secant are straight lines. Now, which way they go depends on whether they're cosecant or secant. Cosecant is horizontal through the coefficient in front. And so secant, if cosecant is a horizontal straight line, then secant must be a vertical line through coefficient. So there's an implied 1 here. So we're going to go from here to the 1 loop, which would be there, and it would go straight across. And that's all there is to it. Now, this is secant. So secant is vertical at, so vert at 1/2. So 1/2 would be here. So guess what? It would go this way and this way. -2 cosecant. So you know that that is horizontal at -2, which would be 2 below. So 1/2 1, 1.5 2. So it'd be here. Straight across. I know. I'm your favorite teacher because I give you all of the shortcuts. Now you can graph these on a graphing device, but I'm not going to show you how to do that. Because I gave you so many shortcuts, these should be super easy to do. All right, that's it for your notes for today. And you should be able to do this really fast and easy. All right, I gave them to you so you don't even have to do this anymore.